students, this is Sivakumar, 11th standard mathematics, chapter number 1, continuation of exercise 1.3. Now problem number 14. The distance of an object falling is a function of time t and can be expressed as s of t that is equal to minus 16t squared. Graph the function and determine if it is 1 to 1. Okay. Here is the function s of t that is equal to minus 16t squared. Have to graph the function, determine if it is 1 to 1. That means you have to verify the given function is 1 to 1 or not, right? Then here s of t, that is distance of an object falling in time t, and t refers time. Okay, for graphing the function, listen, I take the time in x-axis, s of t in y-axis. Time cannot be negative. The initial time can be 0. So I take for example 0, 1, 2, 3, enough. For plotting the points, minimum 2 or 3 points enough. I have taken 4 points. Substitute t equals 0 over here. 0 square is 0, 0 into anything 0. And t that is equal to 1. 1 square is 1, 1 into minus 16 is minus 16. And t that is equal to 2, 2 square is 4, 4 into minus 16 that is equal to minus 64. And replace t by 3, 3 square is 9, 9 into minus 16 that is equal to minus 144. Now we can graph the function. T in x-axis is of t, that is the distance in y-axis. Here we have taken t as 0, 1, 2 and 3. Okay, so what are the points? Approximately I take here minus 16, I take minus 16 over here, minus 64 over here, minus 144, minus 16, minus 64, minus 144, right? First point 0, 0, 0, 0. Second point minus 16, 1, minus 16, 1, minus 16 over here. Third point 2, minus 64, 2 in x-axis and minus 64 in y-axis. Next one 3, minus 144, 3, minus 144, 3 in x-axis and minus 144 in y-axis. So join all the points. You'll be getting a parabolic curve. It's not a straight line. Since look at that degree of the equation 2. If it is more than 1, that should be a curve only. If it is exactly 1, that's a straight line. Since we have 2 in the power, it's a curve only, it's a parabolic curve. For your reference, I write here parabolic curve. So first part is over. Grab the function is over. So here no chance of getting the curve in the left hand side of y-axis because time cannot be negative. We can take only positive values, including that 0. Okay. Now we have to verify it's 1 to 1 or not. For that I am going to consider s of t1 that is equal to s of t2. S of t1 equals s of t2. If we consider s of t1 equals s of t2, if we prove t1 equals t2, then that s is an 1 to 1 function. Okay, consider s of t1 that is equal to s of t2. what is s of t1? Here s of t that is equal to minus 16 t square means s of t1 that is equal to minus 16 t1 square. You just replace t by t1. That's all. Minus 16 t1 square, like that. Here on the right hand side minus 16 t2 square. Both minus minus get cancelled. Even 16 get cancelled. You are proving t1 square that is equal to t2 square. Then we have to take square root. Taking square root on both sides, t1 that is equal to, since we have a square, the square root of t2 square is t2 only, but you have to introduce plus or minus. It is a quadratic equation. Whenever the square in the power, you have to introduce plus or minus. So t1 equals t2 and t1 equals minus t2. t1 that is equal to t2 and t1 that is equal to minus t2. This is not possible because the time cannot be negative. So we have proved t1 equals t2 only. So we considered s of t1 equals s of t2. Finally we have proved t1 equals t2. Therefore s of t is an one-to-one function. Therefore s of t is an one-to-one function. Even you can write one more reason. Different values of t we get different values of s of t. So another reason, say look at the table, different values of t, these are all t values, different values of s of t. So this is another reason for proving that one-to-one. Now one more verification is there. In the graph, if we draw a horizontal line, that horizontal line cuts the curve at only one point, we can say the given function is a one-to-one function. I write the reason also by horizontal line test. The horizontal line intersects the given graph at exactly one point. I put since here. S of t is an one-to-one function. So problem number 13 is completed. For your reference, I draw one horizontal line. See, if we draw a horizontal line, this horizontal line cuts the graph at only one point, so that we can say that is a one-to-one function. S of t is a one-to-one function. So problem number 14 is completed. I will be teaching that problem number 15 in the next video. Thank you, children.